I have here two ramps. Now the black ramp might be a little bit hard to see against the blackboard, but it'll become clear. And if I release a ball here, it'll climb this ramp, come back, climb this ramp, and keep going back and forth for a while until it comes to rest. You hear a little clink when it hits the interface between the two ramps. But the ball keep going for a while. You notice it just stopped abruptly because this side of this ramp is just a little higher than this side of this ramp. And I've got those about as close as I can get them without a lot of a huge amount of effort, because for the purposes of illustration, this is going to work. I've got these thin metal straps, and I can move these straps a little bit to the left or a little bit to the right. If I move it a little bit to the left, this end of this ramp will lower. If I move this one a little bit to the right, it'll raise this end of this ramp. And I simply adjust these until the ramps are as close as I can get them. The pieces of shelf standard, the ramps, are not machined with a high degree of perfection. They're perfectly well designed for their purpose, but of course their purpose is not as a piece of accurate physics apparatus. Now, I've got these aligned, and I simply want to ask what happens. Now, why is it that the ball doesn't go as far each time? Part of it is it's losing energy when it hits this point on the ramp. Another part of it, it's losing energy to the friction, the rolling friction between the ball and the ramp. Now, rolling friction between steel and steel is pretty low, often on the order of just a couple of hundredths or a couple of tenths of a percent. Still, it mounts up. And we'll do some analysis with this, but let's just start by releasing the ball. And I'm going to use these dominoes to mark where the ball ends up. So I'm going to be getting away the camera a little bit, but you'll understand what I'm doing here. Okay, ball came right about there, came right about here, and right about here, and right about here, and here, and here, and here, and here, and I got most of it. Now we can see from these dominoes how the energy is being lost, and it seems, well, we're not going to make an energy interpretation of this, but you do have the idea. I'm going to move these dominoes back here just so they're out of the way so I can roll the ball again with the dominoes present to see how repeatable this experiment is. I know I interrupted my own sentence, but we'll pick it up in a minute. Now, you don't have really good parallax, so it's a little bit difficult for you to see. It seems like the ball's coming up a little bit short of where it was last time. And I think that's probably because I noticed it when I did it. I kind of bumped one of these ramps with the domino, and that offset the point where the two are supposed to join. Let's see. I've got those better aligned. Let's see if that makes a difference. Well, that's actually looking a little better than the first one. And this, of course, allows us to get some sort of a handle on just how much difference that little bump in the middle is making. Yeah, that one actually was a much better run. Do one more run. And I'm going to be in the way of the camera when I release the ball. I don't see a way around that because I need to hold these ends together. I've moved these dominoes up considerably to the point where when the ball is on this end of the ramp, it tends to almost lift that end of the ramp so that any little vibrations will ruin the alignment. That won't be a problem on any of the returns. They won't come past these dominoes, at least I don't believe they will. So let's just see what happens. Wonder where those dominoes were. Okay, one was right about there. I think that's about right. Okay, apparently I've messed up the line just a little bit, but that won't make a whole lot of difference. Okay, let's try again. Okay. Again, you want to think about what changes, what stays the same, and you ought to think about why the system behaves the way it does. Can you analyze the system? Can you explain the behavior of the system? I'm going to increase the slope of this ramp. I will leave the dominoes there. We won't repeat the domino exercise or the placing of the dominoes, but just for point of reference. Let's see what happens this time. Okay. I think the alignment was a little off. Try once more. What did you notice? So think about what you noticed. What happened there that might be surprising? Did the ball come to the same points on this side, on that side? What's different? What's different in this run as opposed to preceding runs? And if anything, what's the same? Okay, one variable is the alignment. The alignment isn't exactly the same in every case, and you would maybe want to analyze just how that alignment affects the motion of the ball on the incline. We can assume that both inclines are straight, or at least we're going to assume that both inclines are straight, so that the acceleration up this incline, for example, is always the same. And the acceleration down this incline is always the same. The acceleration up this incline is always the same, and the acceleration down this incline is always the same. But no two of those accelerations are necessarily going to be the same, for reasons that hopefully you do understand and we'll try to get at with some of the problems.